Hello, this is section 5.4 exponential functions, differentiation and integration together. So definition for the natural exponential functions. Inverse function of the natural logarithmic function f of x equal to ln x and is called the natural exponential function and denoted by the inverse of f in equal to e to the x. So solve for the x accurate to the 3 decimal places. Alright, so in order to do this, you can change to the exponential form to the logarithmic form, or you can just use the rules in here, okay? So e to the ln 2x is the same as 2x. And then so for x, so add 6 both sides, so 3e to the x equal to 14. 3. And then in order to find the x, you can put the ln both sides. And then now x equal to ln 14 over 3, approximately you got 1.540. Okay. Alright, for this one, you just need to put, actually, you can put the e both sides if you wanted it. Or you can say this way too. So this is actually the same as ln of x plus 3 to the half power. You can pull out the half of ln of x plus 3 equal to 1, which is the same as ln of x plus 3 equal to 2. And then you can raise the power as a e as a base, and then you can that one, then you can pull it out as hold on a second, as x plus 3 equal to e to the square. Okay, so subtract 3 both sides. You got x equal to approximately 4.389. Alright, next page. So in the next page, you got ln x minus 2 squared equal to 12. So before I do this, I want to put 2 ln x minus 2 equal to 12. And then ln x minus 2 equal to the 6. And then put the base of e on both sides, which is same as x minus 2 equal to e to the 6th power. And then adding to both sides, you got x equal to about 405.429. Okay, example 2. Sketch the graph of function. So this time, I think I want to use the table for x is a negative 2, negative 1, 0, 1, 2. And plug it in, you got 0 0.1, 0 0.2, 0 0.5, 1.4, and 3.7. So plug it in. So about 0 0.1, 0 0.2, 0 0.5, 1.4, and 3.7. Okay, so if you connect them, these points nicely, and that's a graph of the exponential functions. Okay, so now theorem 5.10, operation on exponential functions. So this is first one is about the product rule. So when you multiply same number with the exponent, you just need to add the exponent with the number you multiply. When you're dividing, you subtract the exponents. So the first one we call the product rule, second one we call the quotient rules. And then also the domain for the exponential function is always a real number, range is 0 to infinity. And then function f of x is just continuous, increasing one-to-one function, entire domain. And then always concave upward for this case. And then and when x goes to negative infinity, goes to 0, positive infinity goes to positive infinity. Okay? All right. So let's solving it out. But before we do the theorem. So theorem for the derivative, okay? Derivative of the natural exponential functions. So derivative of d dx is e to the x dx, and then d du, e du to power is eu, and d you need to use the chain rule for the expression of u. So derivative, right? So which is y prime is e to the negative x squared, and then you got derivative of negative 2x. Okay, so you got y prime is negative 2x e to the negative x squared. The du, dy, dx, y prime is, okay, you have to use the product rules, right? So you got 2x e to the negative x, and then plus of x squared e to the negative x, so negative 1. And then simplify, I got 2 e to the negative x minus x squared e to the negative x. Factor out the GCF as x e to the negative x. I got 2 minus x. For the number 3, I want to use y equal to ln of 1 plus e to the x minus ln of 1 minus e to the x. Okay, so and then y prime is going to be the u prime over u. So e to the x over plus 1 plus e to the x minus negative e to the x over 1 minus e to the x. And then if you put together, I got 1 plus e to the x times 1 minus e to the x. E to the x times 1 minus e to the x minus plus e to the x times 1 plus e to the x. And then when you distribute it, e to the x minus e to the 2x plus e to the x plus e to the 2x over multiply 1 minus e to the 2x. Then this cancels. You got 2e to the x over 1 minus e to the 2x power. Okay, so that's for the number 3. Okay, so number 4. Now I have a y equal to e to x minus e to the negative x. So dy dx or dy prime doesn't matter. I want to pull out the half of it. And then you gotta get to the derivative of the e to the x minus e to the negative x of negative 1. And then you got half of it becomes e to the x plus e to the negative x. And that will be same as over 2 as e to the x plus e to the negative x. Okay, number 4. Find the equation of the tangent line to the graph of function at the given point. Okay, so which is we need to find the first derivative, find out the slope for the tangent line, right? So y prime is e to the negative x plus x squared times negative 2 plus 2x, which is now you can find the slope, right? With x equal to 2. So plug in e to the negative 2 of 2 plus 2 squared of negative plus 2 times 2. And then you got the e to the 0 of the negative 2 plus 4. And then e becomes a 2. So y prime is a 2, meaning that's a slope, right? So I can use y minus y1 equal to m times x minus x1. So y minus 1 equal to 2 times of x minus 2. And then so for y, I got 2x minus 2. Okay, and for the number 2, so y prime is product rule, right? So x become 1 e to the x and plus and then x e to the x and minus e to the x. Now x equal to 1 e to the first power 1 times e to the first minus e to the first. So y prime is e. So now equation formula we have, so y minus 0 equal to e times x minus 1, and then y equal to ex minus e. Okay, so that will be the ex, right? Alrighty. Okay, next page. Now integrations. So integration rule for the exponential functions. So integral e to the x dx is e to the x plus c, and the integral e to u du equal to e to u power plus c. So you can use a substitution. So u equal to 3x plus 1. So du is 3 dx. So you can say that as du, dx is du over 3. Pull out the 1/3 integral eu du, and the integral eu is the u power is same as eu plus c. And then 1/3 u is 3x plus 1 plus c. For the second one, I want to say u is negative x squared, which means the u is negative 2x dx. So 5x e to the u. Now dx is a du over negative 2x. And x cancels out. I got negative 5 over 2. Pull it out as a u du. So negative 5 over 2 as a eu plus c. And then negative 5 over 2. And then u is the same as negative x squared plus c. Alright, number 3. Now I want to say u is 1 over x. And then du is negative 1 over x squared dx. So I have integral eu over x squared times negative x squared and du. And then I got negative, pull it out. And then x squared cancels out. I got eu du, which is eu come out as eu plus c. And then u was 1 over x plus c. Okay, alright, number 4. I want to say u is a cosine x and du is negative sine x dx. So I have sine x times u, but dx is a du over negative sine x, which is the negative. Sine cancels. You got equal and then u is cosine x plus c. Alright, now evaluate the definite integral. Okay, so the first one, I can say u is negative x, which is a du is negative dx. So I have just the integral without using the units. Okay, so e to the u and then du over negative du. Okay, I don't have to do negative one, right? So negative du, which is same as negative integral eu du, which is the same as negative eu plus c. And negative eu is actually the negative x from the 0 to 1. And plug it in. Negative e to the negative 1. Negative of e to the 0, which is negative 1 over e minus 1. Same as negative 1 over e plus 1. And number 2, I want to say u is e to the x. Okay, so no, 1 plus e to the x. I want to say 1 plus e to the x. So du is ex dx. The limit. And it's going to be du over e to the x. E to the x cancels out. I got 1 over u du. So 1 over du is ln u plus c. And then ln u is 1 plus e to the x. And then it's from the 0 to 1. Because once you go back to the x, and then you can put the limits. And then you got ln of 1 plus e to the first power, subtract ln of 1 plus e to the 0 power. And then it will be ln 1 plus e minus ln 2, which is 0.620. Alright, number 3. I want to say u is e to the x, which the du is ex dx. So if you got integral, no limit right it because I'm going to convert to the u. So it will be e to the x and cosine u. And dx is the same as du over e to the x. So e to the x cancel. I got cosine u du. And then cosine u come out as a sine u plus c. And then sine was actually u was e to the x. And then from the 0 to -1 to -1 to 0. So plug it in sine e to the 0, subtract sine e to the -1, and then I got sine 1 minus sine 1 over e. Approximately, it's going to be 0.482. All right, that's all. Okay, thank you for listening.